So quartiles are when we split our data up into sort of quarters. So there are 3 quartiles: Q1, which is the lower quartile, Q2, the median, and Q3, the upper quartile. In Q1, the lower quartile, well, 25% of the data is less than this value. Q2, the median, 50% of the data less than or equal to this. Q3, upper quartile, 75% less than or equal to this. So, first of all, if we have discrete data, so anything that's discrete is when where the values are able to take specific values within a range. So we use this when we have a list of numbers, so we just have a set list of numbers that we're trying to find a quartile of, or the median or the upper quartile of, or if the frequency table isn't grouped, so you just have a discrete or a set number in each rather than say 3 to 5, 6 to 8, if it's non-grouped. And the rule for doing this is, to get Q1, well, that's a quarter of the way, 25%, so you do n, and n is the number of pieces, the number of data pieces you have. So you'll do n divided by 4. To get Q2, you'll do n divided by 2, and to get Q3, you'll do 3n divided by 4, or 3/4 of n if you like. And then the bit here is the key. So what we're saying here is that if when you do these 3 sums, if you get an integer, so that's a whole number, and let's call that r. Say when you do this, you get r as an integer. Then the quartile is between that r and the r plus 1th value. So it's between r and the next one up. So if r was 5, it would be between the 5th and 6th. If r was 6, it would be between 6th and 7th. If r was 10, it would be between the 10th and 11th. So if you get a whole number answer, it's between that and the next one up. And the only other option you can have, you either get a whole number or you don't. So if it's not an integer, so any type of decimal, 3.1, 5.78, any type of decimal, each decimal will lie between 2 integers. So say I got 3.1, well that lies between 3 and 4. Then the quartile, the value that you're looking for, is the r plus 1th, so the upper one of that. So you round up, say, no matter what your decimal is, you go up. So if you had 3.1, that would give you 4, so it would be the 4th value is your quartile. So the other option we have when we're looking at quartiles is that instead of discrete, the data could be continuous, and this is normally if you're looking at a group frequency table. So in this case, group frequency table, you take your data as continuous. So if it's continuous, all we basically do is we don't worry about any other rounding. So to get Q1, we just do n divided by 4 and we find that value. If we want to find Q2, we just do n divided by 2 and find that value. If we want Q3, we'll do 3/4 of n, or 3n divided by 4 and find that value. And to find the values, when it's grouped, it's continuous data, then we use interpolation. So we need to use that interpolation to find that actual value. And the interquartile range is found by doing Q3, so your upper quartile, take away Q1, your lower quartile, and we'll come back to look at that a little later. So there's an example here that we've started. Find the quartiles and interquartile range of this value. So I've started with the median. So n is 11, so all I've done is I've counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces of data, so n is 11. So to get the median, Q2, going to 11 divided by 2, so 5.5. This is discrete data. They're all taking specific values, so we want to get the 6th value. We round up, so 5.5 is between 5 and 6, so we want the 6th value. So all I've done is counted in 1, 2, 3, 4, 5, 6. There we go, so Q2, or the median, is 6. Okay, in the same way, so we got as far as saying that the median was 6. Q1, the lower quartile, will do 11 divided by 4. It's 2.75, so we want the 3rd value. 1, 2, 3, 3rd value is 3. Q3 is 3/4 of 11, that's 8.25, so we want the 9th value. Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, that's 10. The interquartile range is just Q3 minus Q1, that's 10, take 3. The interquartile range in this case is 7.